Hi, Hawaiian Shirt Coder here again, and this is another Hawaiian Shorts session. Ever wondered how to hook up a web API to your .NET client application? In this video I'm going to show you a quick way to do that. Hawaiian Shorts videos are designed to get you up and running all in one video. So let's get started. So in this video we're going to walk through the process of creating a client application in ASP.NET Blazor WebAssembly. And the purpose of this video is to show a quick way to connect to an existing API in order to create your client application. So first of all, I'm going to show you the API that we're going to connect to. It could be any API. In this case, I'm going to use an API I've created or partly created in another series called my Web API series, and the API in question is the sports management system. So I've got this on my other screen and I'm just going to pop it up to show you. And this is only a subsection of the sports management system, but it is the part of the system that allows you to administer fixture data. So you can get fixtures in the system, you can post a brand new fixture into the system, you can get an individual fixture in the system, you can delete a fixture from the system, and you can update an existing fixture in the system. So this, as a sample API, will be good enough for us to demonstrate using Blazor WebAssembly to consume a web API in order to create a client application. So I'm just going to show you what some of the data looks like. So if we get all fixtures through the Swagger tryout method and go execute, we get some data back about a fixture. So we've got 3 fixtures, and this is backed by a SQL Express database in the background. That's the typical shape of some fixture data. And in turn we can also go and add a brand new fixture. So let's just do that very quickly. So opponents at Everton, let's make it an away fixture. Let's say the game starts at 3 o'clock. Some made up postcode, and we need, for this fixture, we need 11 players. So hopefully that's in the correct format. Let's just post this. And we get a 204, which means it's been successfully posted to the database. So if we go back to get fixtures, execute, we now got Everton in the list. So that's good. So we're basically going to try and create a client front end, a UI, using Microsoft technologies, C#, but for this particular video I'm going to do it in Blazor WebAssembly. So let's get started with that then. We can drag this over to my other screen, and I've got Visual Studio 2022 open, and at the time of recording the latest version of the .NET core framework is .NET 7. So what we want to look for in the search bar is Blazor, and we don't want a Blazor server app, we want a Blazor WebAssembly. So let's open this one up and go next, and let's just do call this client app. and go next. We're going to use .NET 7. We're not interested in authentication for this video. We're going to configure for HTTPS. We don't need a host because we've already got our API. We don't need to host one as well. We're not interested in a web, but progressive web application, and we can leave this unchecked. So yeah, all the defaults are fine. Go create. And here we go. So here's our boilerplate Blazor WebAssembly application. Let's just run it up, just check it all builds. So this is what you get with the Blazor WebAssembly template out of the box. That's fine. And we've got our standard stuff that we get with the template. We've got our counter, and we've got a sample of fetching some data. So all of this is a client-side app. Everything is running in the client like a JavaScript framework. This is acting as a SPA. So let's start trying to connect up to our web API in our client Blazor application. So there's several ways of doing this, and I'm going to show you a quick way that handles a lot of the HTTP plumbing that you normally would have to do. So if we go to Program CS, where we hook up all our middleware and all our pipeline, you can see by default the Blazor WASM project comes with this default in here that's saying I'm going to use the HTTP client in order to make HTTP RESTful calls across the internet. So that's perfect for what we want in terms of talking to our web API. But I'm going to show you a quicker way of doing this than having to configure all the HTTP client, and it's using a third-party package known as REFIT. So the first thing that we need to do is we need to go to Dependencies, Manage NUGET Packages, select Browse, and then search for the NUGET package of REFIT. Scroll up, and we need these top two. So we need the REFIT core library, and we also need the refit.http client factory. So let's pull these down, install, and install. So that's all good. And the next thing that we need to do is we need to go and create a new folder in our application to house a service. So let's call this services. And the only piece of data we can get from our web API at the moment is fixture data. So we will create a fixtures service. But it won't actually be a concrete implementation. It will be an interface. So if we go add, new item, interface, then I'm going to call this iFixture service and go add. And this is where the magic will start to happen, or it'll look like magic. So what we need to do next is, if we have a look at our web API, what we need to do here is basically in our service we created in our Blazor client, is we need an endpoint to match each of these. So that's what we're going to do now. So let's just drag this over to the side for a moment. So the first one we're going to implement is the get all fixtures. So this is a public, it's a task of I enumerable. For the time being, I'm just going to make that an object, and I'm going to call this get all fixtures. Doesn't take any parameters, and now what we need to do is add in the refit part of this. So what you do here is this requires an annotation. So you go get, open bracket, close bracket, and we need to go control dot to bring in namespace, which is using refit. And what this needs is it needs a endpoint. So back over here, if we run this and go execute, we can see that the endpoint is https://localhost port 7064/API/fixture. Now, this, of course, this is all running locally on my machine, but if this was on some other address, say up in Azure or whatever, it would look different. But that doesn't really matter. The only bit we need in our annotation is the last bit, because this first bit we will deal with in our program CS in a moment. So we lift out the /fixture, put that in quotes, and that goes there. And at this stage, that's all I'm going to do in here. We will come back and we will implement the other methods that are part of our controller, but I just want to get this one up and running quickly just to show you. So yeah, we'll also have another method signature in our interface for posting, getting one fixture, deleting a fixture, and updating a fixture. So now we need to do a bit more refit configuration, and we do that by going to the program CS file. So I've got that on my other screen, so let me just get that information up. So we go into program CS, and the first thing we need to do is at the top we need to bring in a user statement using refit. And then what we're going to do is we're going to comment out this HTTP call, because we don't need it anymore, because refit is going to handle all the HTTP client plumbing for us. So what we need to add here is builder.services.add refit client, and it's a refit client for our interface we've just created, which is called iFixture services. Bring in the using statement for that. So that's good. And then we need to configure it. So we open close brackets, and then we go .configure HTTP client. C lambda curly braces, hit return. So in here is where we add our configuration, and there is only one bit of configuration we need, and that is the c.base base address, which is new URI, open bracket, close bracket, close quotes. So what I need to do is just go back to my web API that I'm trying to call, which is here. We just run this one again. What we need is basically everything before we get to the fixture part. So copy that out. That is our base URL, because whichever one of these other methods we call, it always has this same bit at the front. So we pop that on there. So that is our base URI. That should be an equals. There we go. And that's the configuration done. And we need a semicolon on there. So as you can see, our client app doesn't have a reference to our web API or anything like that. It's making a call over HTTP to this endpoint, and then in our interface, it's depending on which one of these methods we call. If we call get or fixtures, it is concatenating /fixture on the end. It knows it's a HTTP get, which in the background REFIT will do all the wiring up to actually turn this interface into an implementation on the client of our endpoint, which is here. So REFIT does all the plumbing of actually creating almost a proxy through to our URL address in order to pull the data back. So the one thing that we need to do now is to test it out. So there's one other part is, at the moment I've left this as object. Now if I go and have a look at my web API code, which I'm going to just drag over here a second. And there we go. So we're not too interested in this. If you're interested in actually creating a web API from scratch, I can highly recommend looking at my web API series, where this is the actual web API that we build out. But I've just brought this over so we can have a look at the getAllFixtures method signature. And what I need to do is go and have a look in a service class and find the getAllFixtures piece of data. So this is players. There we go. So this is the bit we're interested in. So what our getAllFixtures web API endpoint returns is a list of fixture summary DTO. So what I'm going to do is, for speed, I'm just going to copy this and we're going to use that on our client side. What we could do is have a shared library that both our web API has and also that the client can consume, so we wouldn't have to repeat code. But I just want to do this just to show that there is no linkage between the two at all. The only linkage is through making a HTTP client request. So we could drag this back out the way, and then in our client I'm going to create another folder. I'm just going to call this let's call it models. That will do for now. And then we'll create a new class. Just leave it like that for the moment, and then we will paste that in there, and then we'll rename our actual class file to that. Okay, so we've now got the same shape on the client as we've got on the server. That was the whole purpose of doing that, really. So now we can say back in our iFixture service that this method, rather than turn an IEnumerable of object, will return an IEnumerable of fixture summary DTO. There we go. So that's the basics of wiring one up. Let's actually make use of this now in a page. So again, this isn't a full how to write Blazor video. It's all about consuming a web API in a quick method, that method being refit. So I'm going to repurpose the index page. So what I'm going to do is call the page title refit demo. I'm going to get rid of all of this stuff. I'm going to create a code block. And then what I'm going to do is I'm going to create a private IEnumerable of fixture DTO. We're probably going to have to bring in some using statements in a moment, and I'm going to call this fixtures. There we go. So we'll bring in the using statement up at the top of the page. And oh, that's because I've misspelt it. There we go. So that's good. Then what we're going to do is we're going to inject our iFixture service into this page. Now, dependency injection in Blazor is done slightly different to in other areas of C#. You don't have constructors in these pages. Instead, you use the inject keyword, and you will say, I want to inject an iFixture service, which again it won't know what that is, so we have to bring in a using statement. We could place all these using statements in a global using, but as this is a demo, I'll just leave it here. And then you give the iFixture service a name. Let's call it fixture service. So that's the dependency injection wired up. So when we come into this page, it says I want an iFixture service. In the background, that iFixture service will go through refit, and it will create almost like a proxy service that knows how to go and get the stuff from the source, which is the web API. So next what we need is I'm going to put a protected override on initialize async. So what this is going to do is this is a method that will get called as soon as we hit the page. Whatever we put in here will get fired straight away. So what we want to do in here is go pluralize that to fixtures. Let's call this fixtures equals, this also needs an async in there, fixtures equals await fixture service dot get all fixtures, because that's the only method signature we've got in there at the moment. Okay, so what this is doing basically is when the page loads up, it's saying make a call to our service, which is an iFixture service. Even though we haven't implemented any concrete implementation of iFixture service, refit has done that for us, and then we've called the get all fixtures method, and that will return, or should return, a task of IEnumerable fixture summary DTO, which will get written into here. So let's see if we can output any of this onto the screen. So up in the actual markup section, we will first of all do a check. If fixtures is not null, tag and say loading data. So if fixtures is not null, it means that the fixtures call has been successful, so we will have a list of fixtures. So what we could do is just loop through that list of fixtures and output them onto the UI. So we do a for each. We can say for each f in fixtures, and we won't do anything particularly elaborate in terms of UI because I'm not very good at making things look pretty. Is we will just stick it in an unordered list. So let's just move that outside of the and then we will do li, and we will be able to access the properties of each fixture. F dot, and then we can say we've got access to all the properties of a fixture summary DTO. So just for a quick demo, what we will do is we will just put the opponent and then we'll put the date perhaps. Let's do that. So let's go. We'll make that to short date times string. There we go. So let's give this a go and just see if it will work. So in order for it to work, we definitely need our web API running, which if this was deployed it would be running, but as it's running on my local machine I just need to make sure that I've remembered to spin it up. So I have closed it, so I do need to start it up again. Let's just do that. So our web API is running. Let's try out our client with the one method in it. So let's go play on this. Loading data, there we go. So that has added our new client with actual live data from an external web API, so that's good. And we can just try this out by posting in a new fixture and seeing if that takes on all the information that it needs. So let's try post on this. That returns a 204. If we go back to the get fixtures, try out, execute, we've now got Spurs in our database over here. So if I just refresh this page, there we go. Spurs has come in as well, so that's good. Just out of interest, have a look at the dev tools. Go to the network tab. I'm going to do a Control F5 on this again. Back to the network tab. And this call here is where REFIT is doing its magic and wiring up all that HTTP client in the background and making a call to our external resource for a get. And here's the data coming back, which is exactly the same as what we've just seen in Swagger, including our new fixture, which is Spurs. So all that's good. Let's stop the application. So before we start going on and wiring other things up, I'm just going to say one last thing about REFIT. So one of the other advantages of REFIT, other than saving you having to implement a service on your client application, is that it also deals with all the issues that you get with HTTP clients. So with HTTP clients, in the past you've always had to wrap them in using statements so they get disposed properly, and even that can be problematic. And if you have a very heavily hit application, even with using statements, you can end up experiencing something known as socket exhaustion, and it stops working. With REFIT, all the HTTP client sockets are managed. So through a HTTP client factory, which was all part of the stuff that we brought in as one of the dependencies. So this one. So that's another issue we don't really have to worry about because REFIT will handle it for us. So I'm the Hawaiian Shirt Coder. That's the end of this session. Please remember to like, subscribe, share with your friends. Remember, keep learning, keep exploring, keep developing, and I'll see you next time.